Thank you for a nice talk. I'm Talha from Northeastern in Boston. I wanted to ask that did you guys get a chance to test if the fans would get broken if you're doing these experiments? Like maybe if you're doing this setup for one day, the fan would stop working?
We actually didn't do the durability study, but in terms of industrial use, I think the fans were tested by the manufacturer to run continuously under high load for a long period of time, much longer than 24 hours. I think that's something we didn't consider, and we assume it will be much more durable than what SpiralSpy hurts it.
That makes sense. Yeah, I was just concerned with the changes in increase and decrease that are rapidly happening. But thanks.
Right. Thank you.
Hi, very cool concept. So I have a question regarding the frequency shift keying that you mentioned. So what kind of modulation index, or what's the limit in terms of modulation index that you can achieve through this type of encoding?
Sure. So the idea I mentioned previously was amplitude shift keying, which used the difference of fan speed to represent different bits. But the limitation here is the time that it requires for the fan to change from one bit representation to the other one. For example, if it takes 20 seconds to send one bit of 0 and then another 20 seconds for a bit of 1, then the system is just not practical. The current limitation is that it's with our algorithm, it can be controlled, for example, from 50% fan speed, which is around, say, 2400 RPM, to 51%, that's 2440 or 2480 RPM in 0.25 seconds. So about 2 BPS for one fan. That's its own limitation. But this is based on PC cooling fans. If we use a system that's designed for rapid controlling, for example, a drone's propeller system, then this limitation can be significantly reduced.
Okay, thank you.
Thank you.
Thank you. I have a question regarding the fans. Do you have to know beforehand the type of fans and number of fans in order to perform an attack, or can you kind of evaluate that as you go?
We thought about this problem, and there are so in our paper, the assumption is that we know the number of fans, and then which allows us to do multi-channel attacks. So for example, if we have 3 fans, then we know that each signal we're receiving can be decoded into 3 parts. But the idea of testing the number of fans can be done with wireless signals beamforming to sense, for example, at each spatial location, whether there's a fan, and then we just count the total number in one run.
Okay, thanks.
Okay. Any other questions? So I also have a couple of questions. So what are the limitations of this SpiralSpy in larger scales?
Sure. So currently, to make this system even more scalable, mmWave sensing has its own, for example, limitations when you're trying to sense it in very isolated locations. For example, if you have a system that's, for example, blocked by a wall of 1 meter thickness, then there's no way for our signals to penetrate that wall and reach the fans for any sensing capabilities. So that's from the RF perspective. And then if you change it to other, for example, wireless modalities, then it might have better performance. But so far, we find mmWave sensing as a sweet spot.
Thank you. And also, could you explain if there are any other devices that can adapt SpiralSpy for covert channel attacks?
Right. So the idea of this is that we can use any object with rotary motion. So, for example, fans that are not in PC cooling that are used for example, ventilation purposes in a building, and then, for example, a more like fantasy-like idea would be like vehicle tires running on the road, and then they're modulated with insignificant amount that wouldn't cause a like lane deviation or something. And then lastly, the drone is a very good application for this with its fast propeller speed changing capabilities.